Today we're going to do section 7.1, ratio and proportions.
Yes, you got Keystone.
As you look at this here, ratio and proportions, both those should be terms that are familiar to you. What's it mean to be a ratio?
There's like the thing in the semicolon or a colon.
Okay, it's that thing, semicolon. Yeah. Okay. What's a ratio? Give me an example of a ratio.
Oh, dogs to cats.
Dogs to cats. That's a great example. Okay, dogs to cats. If somebody were talking about, how many dogs somebody has, how many cats they have, that's a ratio. We can compare ratios in here, boys to girls. Okay, that's a ratio.
I don't get it. It's like, I know it's like, 3 for every 1 cat. I don't know, 3 dogs for 3.
Depends if you have a crazy cat lady or not.
Yeah, if she's lonely, then she has more, she has less.
Cats I just will.
The amount cat Spencer has, the amount cats Caden has, the ratios.
Caden doesn't have a cat. Spencer has a cat.
There's 2 cats.
Anyways, here it is. So ratio is a comparison of two numbers by division. Ratios can be written in various forms. So if you look here, you have x to y, you have x colon y, then you have as a fraction x over y, where x or y cannot equal 0. Okay. Ratios comparing 3 and 2, so 3 to 2, 3 colon 2, 3 over 2. Slope is also a ratio. What is slope a ratio comparing?
Rise over run.
It's the rise to the run. Yeah, slope is actually a ratio comparing the rise to the run. So if I look here at my coordinates, if I wanted to find the slope, I would compare the rise. How much did I rise here?
1, 2.
Over the run, how much did I run there?
4.
So 2 over 4, which equals 1/2.
So it'll be 1 colon 2.
1 colon 2. Nice job, because the slope there would be 1 colon 2. You can also use the ratio of angle measures in a triangle. So for example, down here, the ratio of the angle measures in a triangle is 2 to 3 to 4. What's the measure of the smallest angle there? Wants me to find? Well, that's like saying now I have 2x, 3x, and 4x. And because it's talking about the angles in a triangle, what are the angles in a triangle always add up to? 180. So I would set 2x plus 3x plus 4x equal to 180 and solve for x from that. Okay, so you can use ratios to help us solve problems. First thing we're going to do is we're going to look at these 3 problems and find the ratio of the slope. Again, what's the ratio of the slope? It's the rise over the run. So if I look here at number 1, A to B, I'm going to rise how many?
2.
And I'm going to run how many?
6.
So 2 over 6, which simplifies to?
1/3.
There's my slope, 1/3. 2, I'm going from C to D. C, how many should I rise from C? Anybody?
4.
8.
2.
Over 2, so 8 over 2.
4 over 1.
Which gets me 4 over 1. Nice job.
Do we have to put it in a ratio? Do you have to put it in a ratio form?
That is a ratio form. Fraction is a ratio form as well. Remember, that's one of the 3 forms? Yep, that's one of the 3.
Can we put it in below?
Yeah, you can if you want to. 3, E to F. Okay, E to F here. Now notice, what am I doing here? I can't rise. I'm actually going to fall. I'm going to go down. So if I'm going down, what's my ratio? It's going to be -3 over how many? So -3 over 2.
How do you write it? Do you put that?
Just like that. Yep. Using that same idea, take a couple seconds, try these 3 on your own. Find the rise over the run, find the slope of these 3 lines. Alright, number 4, quiet down. N. Trent, what do you have for the slope of N? -5 over 2. Becca, L, what do you got? 3 over 2. And M, oh, I don't know, Simeon, what do you get for M?
-1.
Nice job. So that's the slope, rise over runs. Great job. Okay, now we're talking about the ratios in the triangles. For example, the ratio of the side lengths of a triangle is 2 to 4 to 5, and the perimeter is 55. Who can remind me, what's perimeter mean? Distance around the outside, nice. So if the ratio is 2 to 4 to 5, that's like saying 2x plus 4x plus 5x, and I would set that equal to what?
55.
Okay. Why would I set equal to 55?
Because 55 is the number.
Yeah, 55 is the perimeter there. So when I do that, 2x plus 4x plus 5x, I end up with 11x equals 55, which is x equals 5. Now, what am I going to do with that x equals 5? I need to answer the question. It says, what's the length of the shortest side? So where's that 5 going to go into? So what's 2 times 5? 10. Nice job. 8. The ratio of the angle measures in a triangle is 7 to 13 to 16. What's the measure of the largest angle? Jake O'Connor, how would I set that up? And what would I set that equal to now, Jake? It's talking about the measure angles in a triangle. So what's it going to be? 180. Why 180, Jake? Yeah, talking about a triangle here, right? So the measures in a triangle add up to 180. So 7x plus 13x plus 16x. When I do that, I end up with 36x. Shh, quiet. 36x equals 180. Or x equals 5. Now this one asks me, what is the measure of the largest angle? So I'm going to take the x equals 5 and plug it into where? So what's 16 times 5? 80. So I'm going to get 80 degrees. Nice job. So make sure you answer that last question. Don't just solve and think you're done there. Make sure you go back and answer what's the last question state. Last thing we're talking about today is in ratios, we can also solve for some missing ratios using proportions. Now, we should all understand proportions by now. To work proportions, what do you have to use to solve those? Cross products. Okay? So we use cross products to solve proportions. If you need an idea, you can look over there to that poster on that far wall. Okay?
Golly gee, how you doing, Mr. Daly?
I'm good, Cindy, and how are you?
Good.
Good. So if I look here at these proportions, I can use cross products, 35 times 8, and then 56 times x. Okay, cross products and solve. Or, now, instead of using cross products, I can also use equivalent fractions. For example here, 8 times what is 56? 7. So I take it times 7. So what times 7 is 35? 5. Guess what? I get x equals 5 either way I work it out. For problems like this, it is much easier to use equivalent fractions. Okay? If there are tougher problems where you cannot see what multiplies or divides, yeah, cross products is probably easier. When it comes up here, unless my thing froze. Alright, so let's try number 9 here. I want to use some cross products or equivalent fractions. 9 over t equals 36 over 28. When I look at it here, let's think about the numerator here. 9 times what is 36? 4. So t times 4 is 28. So what's t have to be? 7. 7 times 4 is 28. Because you multiply by 4 by 4. 10. X over 32 equals 15 over 16. Let's look here. 32 divided by what is 16? Or I could say 16 times 2 is 32. So 15 times 2 is? 30. X is going to be 30. You see how we can use equivalent fractions to solve some of these problems. Makes it easier. 11. 42 and 7. What's that number going to be there? 6. So I divide by 6. 24 divided by 6 gets me? Did you say 11? I think you're off, bud. 24 divided by 6 is what? 4. Y equals 4. Thank you. And last one here, 12. This is a little bit tougher one. Pay attention here. Okay. As you look here, I mean, you could probably figure it out maybe with some guess and check. But let's try cross products here. What's 8 times 3? Okay. Now what's 2a times 3a? 6a squared. So our 24 equals 6a squared. Now I want to solve for a. So what am I going to do on both sides first? Divide by 6. What's 24 divided by 6? So I have 4 equals a squared. Now pay attention here. What undoes a squared term? So I do the square root. Square root of 4 is? 2. Ooh, so close. It's actually, no, that's half your answer. What's the other half? 1.5. Out of the 2 students? Plus or minus 2. You get a equals plus or minus 2. Why is it plus or minus? Because it's the square root of 4. Square root of 4, as we all know, is 2, but it's also actually negative 2. Negative 2 times negative 2 is also 4. Negative 2 is also 4. So you actually, when you're doing equations, need to include the positive and the negative. Okay, so recognize, you won't have a lot of problems like 12, but you might have a few. Take a couple seconds, try these 3 on your own. Number 13, Luis, what do you have for answer 13? A equals 5. How'd you do that, Luis? What? Did you use equivalent fractions? Like 16 divided by 2 is 8, so 10 divided by 2 is 5. Nice job. 14, we have for 14, Heston.
6.
B equals 6. How'd you do that, Heston?
Oh, yeah.
Divide by 3.
So you divided by 3.
Then you multiply it by 3.
So multiply by 3. Yeah, there you go. 15, you get what, Reed?
10.
C equals 10. Nice job. How'd you do that, Reed? Times it by 10. So take this one by 10. Same idea. Again, recognize proportions. You can also use the equivalent fractions as well. Here's your assignment.